Hi everyone, thank you for joining. So in this video we're going to solve another interesting integer equation, but this time rather than finding the integer solutions, that we're going to prove that there are infinitely many integers satisfies this equality, right? Now x and y are strictly positive integers, right? If you'd like to pause the video here and try it yourself first, then we could go with it together. Well, this is a proof question, which means there are so many different methods or approaches to prove this equality. And one way to do that is, if we expand the left-hand side, we'll see that we have x squared minus 2x plus 1 plus x squared plus 2x plus 1. So that will go. In other words, we'll have 2x squared plus 2 is equal to y squared plus 1, right? We could use some clever substitution that will show that indeed this equation will have infinitely many solutions. And one way to do that is, if we let x to go to 2y plus 3x, let's see what we've got. So in other words, if we replace x here and there by 2y plus 3x, since x is an integer, y is an integer, so there is nothing wrong with the substitution, we will have 2y plus 3x minus 1 squared plus 2y plus 3x plus 1 squared. And so if we expand to see how much we've changed the original equation, we will have 2y plus 3x squared minus 2 times 2y plus 3x plus 1 plus 2y plus 3x squared plus 2y plus 2 times 2y plus 3x and plus 1, right? So this will go with that. We will have so let's expand that. We have 4y squared plus, so that's 12xy plus 9x squared. And we will just have the same thing here. So let's just double it. Plus 2, that's 1 plus 1, right? And if you write it explicitly, we have 8y squared plus 24xy plus 18x squared plus 2, okay? So as you can see, that the left-hand side is quite different than the left-hand side here. So we've changed the equation significantly. But if we change the right-hand side of the equation as well, so that we get the original equation, so that right-hand side balances the left-hand side, what we must have here is 9y squared, because 9y squared take away 8y squared will give us the y squared we want, right? And then on the left-hand side, we have 18x squared, but we want that to be 2x squared. So we add 16x squared on this side. So that will this will bring it down to 2x squared. We want to get rid of 24xy, so that there is no xy expression on the left or right. And if we plus 1, we're going to have on the right-hand side y squared plus 1 after we do the cancellations, right? So which means that we can write it as in the initial form, that we have 2y plus 3x minus 1 squared plus 2y plus 3x plus 1 squared is equal to, well, it's not very difficult to factorize this. If you look at the numbers, we will have 3y plus 4x squared. So that will give us everything we want except 1. So we have to plus 1. Okay. So in other words, the original equation that we had, which was x minus 1 squared plus x plus 1 squared is equal to y squared plus 1, can be written like that. And what is the advantage of this? Well, this is in disguise, this is hidden now, but we've proved that there are infinitely many solutions to this equation. Because for any x, given x, there will be larger integers, which corresponds to 2y plus 3x and 3y plus 4x. Yeah, for any given x and y, we will have larger integer solutions. Now, to see this explicitly, let's guess the first solution. So the first solution obviously that x is equal to 2, y is equal to 3, or in fact 0, minus 1 and plus 1, isn't it? So this will solve these equations. Just to ensure that we understand that this indeed solves. So if x is 2, we have here 1 squared plus 3 squared. And the y squared is 3 squared plus 1, so it solves the equation, yeah? Okay, so now what this is saying is that for any given xy, you can replace it x with 2y plus 3x and y with 3y plus 4x, and that will also be a solution. In other words, once we find one solution, there will be infinitely many solutions, but let's do it explicitly. So let's use 2, 3. So 2, 3, right, that will correspond to 2y, so y is 3, plus 3x, and then 3y plus 4x. Let's look at these numbers. So what are these numbers? So we have 6 plus 6, which is 12, and then we have a 9 plus 8, which is 17, right? Let's test with the original equation. So we have, if x is 12, we have 11 squared plus 13 squared. Now, is it equal to 17 squared plus 1? Okay, so 11 squared is 121 plus 169. So that will give us 290. Now, is it equal to 17 squared, which is 289 plus 1? The answer is yes, indeed, it is equal to, right? So the next solution we have here is that the 12 plus 17, right? And indeed, you can keep doing this. Well, I'm just curious that I want to look at the next possible solution as well. So if we start with 12 and 17, apologies, and if we replace this with 2y, so that's 2 times 17, plus 3x, so it's 3 times 12, 3y, which is 3 times 17, plus 4 times 12, right? So what would that give us? Okay, so again, let's test this. X minus 1 squared plus x plus 1 squared. So we have 69 squared plus 71 squared. Now, is it equal to 99 squared plus 1? Well, the left-hand side is 9802, and the right-hand side, indeed, 9802. Okay, so I think this was an interesting question. Thank you so much for joining. I hope you enjoyed it. I hope you found it interesting. And I look forward to seeing you in my future videos. Thank you.